Hello and welcome back. So we've been talking about finding slope and kind of if you need help finding slope using points on a line or you don't understand, go back and watch that other video. But basically we've come to understand that slope measures the steepness of my graph and basically boils down to a ratio between rise over run. It is how far up or down I go compared to how far left and right I go. So I want to talk about that for just a minute because reviewing it will help build for this subject. So when I was figuring out my run, I made this triangle, and my rise, I made this triangle so I could actually see the change. So I know that I counted the lines, 1, 2, 3. I knew that my run in this particular line was 3, and that my rise would be 1 because I'd go up 1. So anywhere on this line, if I went over 3, 2, 3, and up 1, I knew I'd find a point. 1, 2, 3, up 1, there's a point. And so I can see that ratio goes throughout 1 over 3. Okay, now I want you to think about this. Whenever I'm talking about my run, what does that actually imply? My run is going from left to right. So I am talking about a change. All right, well, in math, we represent the word change by the symbol delta. And delta looks kind of like a triangle, but it's got one side that's a little bit thicker. So I'm looking at the change, but what am I actually measuring? This left and right. I'm measuring my x's because it's the x-axis that it's running parallel to, and I'm measuring how much the x changed from one point to the next. So it's actually change in x. And then I'm also measuring the change in up-down. So I want to know the up-down change. So that is measuring the delta of y. Okay. So if I wanted to represent this in rise over run, I could also say that it is the change in y over the change in x. And now you might find some math people that do a funny formula with sub numbers. So it would look something like x sub 1 minus x sub 2 underneath y sub 1 minus y sub 2. And that's really complicated. And I'm not going to write it down because it might confuse you even more. What I want you to remember, change of y over change of x. Same thing as rise over run. Okay. Now that you have rise over run, and the change of x over the change of y, we're going to erase all of this because we've proven rise over run and the slope of this line is 1 over 3. I want us to remember 1 over 3. And I am going to take away this line. Now, if I still just had those points, of course I could figure it out. I would just plot between them and figure out my rise over run. But what I want to say is I only have the address. I don't have graph paper. I only have the address. Here is the secret. Most of the times they'll be presented to you side by side. And on our worksheet, they are presented side by side. There is absolutely nothing wrong with that. It just doesn't work for us particularly. What I want to do is I want to stack them vertically. So we are going to write, we have line or point 1, 3 and 4, 4. All right, and remember now we're looking at the change of x over the change of y. Well, the way I stacked them, I have my x's here and my y's here. And in fact, I could actually change this color back to the y. And that might make a little bit more sense so you can actually see what I'm doing. And then between them is this bar, this division bar. Let's go on ahead and put a division bar between them. Okay, I'm even going to put an equal sign under here. Now, I want you to think about something. Let's say you went to Walmart, my ball, and you found this beautiful ball. And this ball is $1.25, right? So you take your ball up to the self-checkout stand because who's got time to wait in the line? And you scan it for $1.25. You put in $2. What is the change you get back? Well, it's $1.25. You paid $2. 75 cents, right? Well, how did you know it was 75 cents? What operation did you use? You've got addition, subtraction, multiplication, and addition, subtraction, multiplication, and division. Sorry, had a minor brain explosion. What did you use? You used subtraction. You subtracted the $1.25 from $2. And that money is called your change. When you are finding change in an equation, you are finding subtraction. So let's write that subtraction symbol down. Subtract. And now let's try it. 1 minus 4. If I start off on 1 and I take away 4. 1, 2, 3, 4. I'm going to wind up at -3. -3. That's pretty close to what I was looking for on my slope. I mean, it's negative, but let's keep going. Let's see what happens. And then I have 3, and I'm going to take away 4. So I'm going to start at 3 this time. 1, 2, 3, 4. I wind up at -1. Okay. Well, now rise over run. So which one's going on top? My y is going on top. So I'm going to put -1 on top over, now my run, -3. -1 over -3. What is a negative divided by a negative? Good job. It's a positive. So if I just use these 2 points and subtracted them, I will get 1/3, which is the slope I originally had. So we know it works. We know it's true. Now that I've proven it to you, let's take the quick route to do this. Yep, I can do that. And I'm going to remove these points from the graph and pull these points up on the graph. Change to the pen, change colors, and back at it. So now I'm looking at these 2 points, and I just want them there for you to have a visual. But we're going to go on ahead and write them out stacked, just like I told you to do. So I've got my x, -5, comma, 0 for my y, and that's my first point, and I'm pulling them from right here, and these are actually ones on your worksheet. So, and then my second point, 1, comma, -5. I'm going to do the exact same thing. I'm going to draw my equal sign across. I'm going to put my division bar in between it, and I'm going to say subtract. Okay, so -5 minus 1. -5 minus 1 is -6. If I start at -5, subtract 1 more, I get more negative. Now I have 0 minus a -5. Oh, I said minus and negative side by side. If we subtract a negative, we are, I hope you said adding a positive. I don't get to hear it, so when we subtract a negative, we are, say it louder, I can't hear you through YouTube. When we subtract a negative, we are adding a positive. So this would be 0 plus a +5. 0 plus 5 is 5. So if I put these together, I have my change in y over change in x. So my y is on top, 5 over -6. Now, I want you to know something. This negative, we could easily move it to the top. And most of the time, you would prefer it in the top, and that's just the way it's presented. It's more natural. It just is what it is. But I'm going to prove to you they are the same thing, and I'm going to change the color just to make sure we do. So let's test this, right? So we said rise 5. So if we go up 5 from this point, 1, 2, 3, 4, and 5. All right, so there was my rise. Now I want to run -6. We normally read the book from left to right. Now we're going to read the book from right to left. 1, 2, 3, 4, 5, 6. And the reason we read it backwards is because it's a negative. But look at that. I wound up exactly on that point. So I know that's a good slope. The reason I like the negative on top is because it allows me to read the book the normal way. So if I have a rise of -5 and a slope of 6, I know I am going down 5. 1, 2, 3, 4, 5. And to the right, 6. 1, 2, 3, 4, 5, 6. And look, I wound up from the same spot to the same spot. That proves to you these ratios are actually the same. I just think it's more natural to put the negative on top. It's the way all your answers are going to be in textbooks, and it's just the way it is. It's kind of like why, a weird thing. In American English, we say the blue house. In Spanish, it would be the house blue. It just is the way it is. It's the way the brain works. It's right for us for some reason. Okay, so let's look at one more example before I get too long-winded on subjects like language. We're going to get rid of these points, and let's pull up these points. And let's check. Let's see if we've got this figured out. So I'm going to look at this first point. Oops, yep, there we go. And that point. I'm going to look at these points. My first point's -5, comma, 2. Comma, 2. My second point is 1, comma, -2. I'm going to put my equation bar, my division bar, and subtract. -5 minus 1. -5 minus 1 is going to be -6. 2 minus a -2. Remember, if you subtract a negative, you are adding a positive. 2 minus a -2, same thing as 2 plus a +2. 2 plus 2 is 4. So this is going to be, I'm running out of room, 4 over a -6. I want to pull that negative out and put it up here because I proved those are the same. And now I can reduce. I can divide top and bottom by 2, divide by 2, and I get 2 over 3, 2/3. Sweet. So now let's test it. Let's go. We are going to go, oops, -2/3. Always remember your negative. So I'm going to take my first point. I'm going to go down 2, 1, 2, and then I'm going to go to the right 3. 1, 2, 3. Well, I didn't get to my point. What do I need to do? I need to keep going. Down 2, 1, 2, to the right, 3. 1, 2, 3. And we are there. Now, I want you to notice something. This ratio had the 2/3 in it. If I went 4, 6, the original one, I would have gone 1, 2. Wait, I didn't count this right. 1, 2, 3, 4. And then I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. These fractions I just proved to you are the exact same ratio. So slopes can tell us so much about ratios. Knowing the slopes and being able to plot linear equations will help us understand how to make predictions, how to look at the way things are going in the world, they're spending or they're not spending. Some really cool stuff. Hopefully this helps you. Do me a favor, leave me a comment. Let me know if you liked it, not what you need to know, what you didn't need to know. If there's a subject you need me to cover, let me know that. And then again, like, subscribe, hit the notification bell. I'll see you in class on Monday or tomorrow. It's Wednesday. I'm wearing pink.